The nth power of a number a is denoted by this exponential expression a to the n. N here is called the power or exponent, and the number a is called the base of the exponential expression. If n is a positive integer, for example, n equals 1, 2, 3, 4, 5, and so on, then a to the n is defined as products of n copies of a, or n factors of a. So for example, if n is equal to 4, a raised to the fourth power, or a raised to 4, is equal to product of 4 copies of a. If we have x cubed, this is equal to products of 3 copies of x. The square of x plus y means it's a product of 2 copies of x plus y. And lastly, if we have the cube of a minus 2, this is equal to products of 3 copies of a minus 2. Let us consider the two expressions, 2x cubed and the cube of 2x. So this second expression, it is clear what the base is. The base is 2x, so this means that we need to multiply 3 copies of 2x, 2x times 2x times 2x. In the second expression, the base of the power 3 here is not 2x, but it's only x. So this is equivalent to 2 times 3 copies of x. So it's clear from this expansion that the two expressions are not equal, because the second expression has 3 copies of 2 in the products. If we also look at, let's say, negative x raised to quantity raised to 4 and compare it with negative x raised to 4, okay, the quantity of negative x raised to 4 means we have to multiply 4 copies of negative x. While the second expression means it's the negative of x raised to 4. It's the negative of x raised to 4, which is products of 4 copies of x. If you go back to the first expression, so we're multiplying here 4 negative signs. So negative times negative is positive. So this is the same thing as x times x, and then negative times negative is positive. So x times x. So clearly, these two expressions are not the same. The first expression is actually equal to x raised to 4. It is not equal to the negative of x raised to 4. Now let us review the rules on integer exponents. So let m and n be any integers. For example, 1, 2, 3, 4, 5, and so on, or they're negatives or 0. Here we assume that both sides of the equations are defined. Again, defined means they are real numbers. So the first rule, zero exponent rule, states that any non-zero number raised to 0 is equal to 1. So for example, 2 raised to 0 is equal to 1. Let's say negative 3 raised to 0 is equal to 1, and so on. But keep in mind that 0 raised to 0 is undefined. The next rule is negative exponent rule. So here we have x to the negative n is equal to 1 over x to the n. So as you can see, this is like moving a factor from the numerator to the denominator. So when you move a factor of the numerator to the denominator, you have to change the sign of the power. So from negative n to positive n. Now, if you have a fraction x over y raised to negative n, if you want to make the power positive, then that means you have to flip the base or flip the fraction. So from x over y, you have to write it as y over x. And when you flip the fraction, then you have to change the sign of the power. So from negative n to positive n. So for example, let's say if you have 3 raised to negative 2, so this is equal to 1 over 3 squared, which is equal to 1 over 9. Second, let's say if you have y raised to negative 3, then this is equal to 1 over y cubed. Another example is, let's say you have 2 over x, and then this is raised to negative 3. So if you want to make the power positive, then we just have to flip the fraction. So 2 over x, make it x over 2, and then change the sign of the power. We'll get x over 2 quantity cubed. Now let us move to the next rule. So this is called the product rule. So product rule states that when we multiply two exponential expressions with the same base, x to the m and then x to the n, so the product is just, okay, we copy the base x and then just add the powers. So you have here m plus n. So take note that we can extend this to products of three exponential expressions with the same base. So let's say if you have x to the m multiplied it with x to the n and then times x to the r, then this is just equal to x to the m plus n plus r, where m, n, and r can be any integers. Okay, let's have some examples. Let's say if you have 2 raised to 3 and then times 2 raised to 4, so this is just equal to 2 raised to the sum of the powers, so 3 plus 4, so that is equal to 7. And since m and n can be any integers, so we can have a negative power, let's say negative 5 multiplied to, let's say, 2 raised to 2. So this is just 2 raised to negative 5 plus 2, which is equal to 2 raised to negative 3, which is, of course, equal to 1 over 2 cubed. And 2 cubed multiplying 3 copies of 2, so that is 1 over 2 times 2 times 2, which is equal to 8. So this is equal to 1 over 8. And next, if you have, let's say, x times x raised to 4 times x raised to 5. So in this first factor, so we don't see any powers. If you don't see any power, this means that the power is equal to 1. So if the power is 1, we don't usually write the power 1. So this is equal to x. We add all the powers, 1 plus 4 plus 5. So this is equal to x to the 10. Next problem. So if we have, let's say, a plus 4, and we multiply this with a plus 4 quantity squared. So again, you have here one copy of a plus 4 multiplied to two copies of a plus 4. So all in all, we have three copies of a plus 4. So this is a plus 4 quantity cube. And last example, so let's say we have here 2x cubed and then y raised to negative 5 multiplied to, let's say, 3x raised to negative 3, y raised to 7. So here x and y are raised to negative powers, so there should be restrictions here. So x should not be equal to 0 and then y should not be equal to 0. So this is equal to, let's say, first we multiply the constant coefficients, 2 times 3, and then multiplied x cubed with x raised to negative 3, and then y raised to negative 5, and then y raised to 7. So when you're performing products, you can change the order. Order is not important, and also grouping is not important because multiplication is commutative and associative. So here 2 times 3 is equal to 6. We apply product rule here, so same base, x, 3 plus negative 3 is 0. And then we have here y raised to negative 5 plus 7, so that is positive 2. But when the base is not equal to 0, 0 raised to x raised to 0 is equal to 1. So this is 6 times 1 times y squared, which is equal to 6y squared. Now let us move to the power rules. The first power rule states that this is actually called power to a power rule. Okay, so when a base x is raised to two exponents, so x raised to m and then raised to n, so we just copy the base x and multiply the exponents, m times m. It is very important to know when to add and when to multiply the powers. In the product rule, we have two exponential expressions with the same base. So it states that when you multiply like bases, you add the exponents. So we had like x to the n times x to the m equal to x to the n plus m. But for this first power rule, we only have one exponential expression here, and this x here is raised to two powers or two exponents. We have m and n. And if we have such a situation, we raise the base x to the product of the exponents, m times n. The second power rule, this is power of a product. So we have here the product of x and y. So when we raise a product to a power n, we can raise each factor to that power. So here the factors are x and y. So the nth power of the product xy is equal to the nth power of x times the nth power of y. And the last power rule, this is power of a quotient, so similar to the product. So when we raised a quotient to a power n, we can also raise the numerator and denominator to that power. So you have here x to the n over y to the n. Okay, now let's do some examples. Okay, first, if you have, let's say, x raised to 5 and then the whole thing raised to -3. So we have here base x that is raised to two exponents, so 5 and -3. So using this first power rule, we can write it down as x raised to the product of the exponents, 5 times -3, which is equal to -15. And of course, when we are simplifying expressions, we don't want the powers of the symbols to be negative. So to simplify this one, we have to write it down as 1 over x raised to 15. Next problem, so let's say if you have 3a squared quantity raised to 4. So take note that this is the fourth power of a product, the product of 3 and a squared. So using this second power rule, we can write it down as 3 raised to 4 times the fourth power of a squared. And to simplify this fourth power of a squared, we have to use the first power rule. So this is equal to 3 raised to 4 times, again, a is raised to two exponents, 2 times 2 and 4. So we have to multiply those powers. So we have here equal to 8. And of course, we know that a 3 raised to 4 product of 4 copies of 3 is equal to 81. So this is 81a raised to 8th. Another example, let's say we have negative 2x cubed, y raised to -5, and then the whole thing raised to -3. So keep in mind that this second power rule can be extended to product of three or more factors. So we can have here product of x, y, and z, product of x, y, z, and r, and so on. The only thing that you need here is to distribute the power to each factor. So in this third problem, we have here three factors. Factors are -2 x cubed and y raised to -5. So using this second power rule, so we need to distribute the power -3 to each factor. So we'll get -2 raised to -3, and then x cubed raised to -3, y raised to 5 raised to -3. And we apply the first power rule for the second factor and the third factor here, because the x is raised to 3 and then again raised to -3, and y is raised to -5 and raised to -3. So to simplify this first factor, -2 raised to -3, we have here a negative exponent. So to make the power positive, we can move that to the denominator, move this factor, and we'll get -2 raised to +3. Now, this x cubed raised to -3 using the first power rule, this power rule will get x raised to 3 times -3, which is -9. And then we apply the same rule for this second, for this expression. And we'll get here y equal to negative 5 times negative 3, which is equal to 15. Now, let's do some simplification here because we don't want powers to be negative. So this x raised to negative 9, we can move this factor to the uh, denominator, and we'll get here x raised to 9. And then, of course, we still have the factor y raised to 15 in the numerator, and multiplying 3 copies of negative 2 gives us negative eighth. So we have here negative eighth. If you have a negative sign in the denominator, it is better to write it down, okay, in front of the negative sign, in front of the fraction. So this is equal to negative of y raised to 15 all over 8 x to the 9. And let me give you one more example. Let's say we have x squared and then over y cubed, and then this quotient is raised to negative 3. So we can use here this third power rule. It's the power of a quotient, and we can write it down. So by this third rule, we can raise the numerator and denominator to the power negative 3. So we can get here x squared raised to negative 3 over y cubed raised to negative 3. And applying the first power rule to both the numerator and denominator, we'll get here x equals negative 6 over y raised to negative 9. Again, we don't want negative powers, so we write this down as y raised to 9 over x raised to 6. Also, if we have a fraction, we need to make sure that there are no common factors between the numerator and denominator. Okay, because when we're simplifying expression, we need to make the expression as compact as possible. So if you have a fraction, you need to cancel out all common factors between the numerator and denominator. Now, let's move to the last exponent rule. So here we have the quotient rule. So this quotient rule says that when you divide like bases, x to the m and then x to the n, you only subtract the exponents. So you copy the base, the same base x, and you subtract the exponents, m minus n. So the power of the numerator minus the power of the denominator. So note that we can also think of this x to the m over x to the n as x to the m. Moving x to the n to the numerator, we have to change the sign of the power, so x to the n. And by writing it in this way, we can apply the product rule because we're multiplying two expressions with the same base. So we just copy the base x and add the powers. But the powers here are m and negative n, so that is m plus negative n, which is actually equal to m minus n. Take note that m minus n is positive if m is greater than n. So what if uh, we have m that is less than n. So if m is less than n, so this m minus n here is a negative integer. So to simplify that expression, you need to move that to the denominator. But moving this x raised to m minus n to the denominator will actually give you x raised to the negative of m minus n. And the negative of m minus n is actually equal to n minus m. So this n minus m here is the negative of m minus n. So as you can see, both of these expressions are equivalent. If we look at the second expression again, you can actually move the numerator to the denominator and it will give you 1 over x to the negative m times x to the n. And here you apply again a product rule, which gives you this expression, 1 over x raised to the sum of the powers negative m and n, which is actually equal to n minus m. I suggest that you use this first equality when the power of the numerator m is larger than the power of the denominator n, because this will give you a result which has a positive power. Okay, so m minus n will be positive. Now you use this second inequality if n is larger than m. So the power of the denominator is greater than the power of the numerator. Let's have some examples. So let's say you have x raised to 5 over x raised to 3. So this is equal to power of the numerator is larger than the power of the denominator. So we use the first equation. So we have here 5 minus a 3, which is equal to x squared. Or since these are just positive powers, so x raised to 5 means you have 5 copies of x in the numerator, x cubed 3 copies of x in the denominator. So you cancel common factors. You cancel 3 copies of x in the denominator and 3 copies of x in the numerators. You're left with 2 copies of x in the numerator. So you have here x squared over 1, which can be simplified to just x squared. Another example, so let's say we have x raised to negative 4, y raised to 8, all over x raised to 2, y raised to negative 5. Now, if we look at the quotient, x raised to negative 4 over x squared, since the power of the denominator is larger than the power of the numerator, so it is better to use this equation, and we'll get x raised to 2 minus the power of the numerator, which is equal to negative 4. If you look at the second quotient, y raised to 8 over y raised to negative 5, power of y in the numerator larger than the power of y in the denominator. So it's better to use this first equation, and we'll get here y raised to 8 minus negative 5. And doing the arithmetic in the powers, we'll get y raised to 13 over x raised to 6, which is already in simplified form.